Okay, so we've learned how to use the standard normal table, and we've learned how to work with the standard normal distribution. So remember, what that means, if you're dealing with a standard normal, is that you're working in terms of z. You have a mean of 0, and your standard deviation is equal to 1. That's why it goes 1, 2, 3 to the right, negative 1, 2, 3 to the left. What we want to be able to do now is look at any bell-shaped curve, all right, in terms of our general variable x, with any mean and any standard deviation. All right, whatever those happen to be. And the good news is there's a very simple bridge between these two. All right, for any normal distribution, if you use a z-score formula, you can convert your value of your value of x for any normal distribution to a z-score. It's a very simple formula. Subtract the mean, divide by standard deviation. And if you do that, you go right back to a standard normal distribution where you have mean 0, standard deviation 1. You can use the standard normal table and everything will work the same as it did in section 5.1. Okay, so again, let's look at an example of where this is going to come up. So what I want you to notice as you read through this first example, you are dealing with a normal distribution. All right, you can see it right here. That means you do have a bell-shaped curve. But notice that your mean is not 0 and your standard deviation is not 1. That's how you know this is in terms of x, not z. Z, the standard normal, must have mean 0 and standard deviation 1. So notice what I did here first. I sketched it out. All right, I read through the problem and I said, okay, the average speed, average and mean are the same thing, is 67 miles per hour. That's my center. Mean is always at the center. And then I pulled the standard deviation, the unit of variation, at 3.5. That's what told me how far to each one of these 3 marks on either side of the mean. I'm just moving out by the standard deviation, which here is 3.5. All right, that gives me a good sketch of what's going on here. And so then what I'm going to do is I'm going to make sure that I understand the area that I'm being asked to find. All right, so I notice right here I'm asked for a probability. All right, and I know from the previous section that probability and area are the exact same thing. Now, I also know that area is always directional. So I've got to make sure I understand, am I looking at less than, greater than, or in between? And so if I continue reading here, it says, what is the probability that a vehicle is violating the 70 mile per hour speed limit? All right, well, we all know if you're violating the speed limit, you're going more than the 70 mile per hour speed limit. So now I know not only am I looking for an area, but if I want to go greater than, I'm looking for an area to the right of 70 miles per hour. All right, so again, I can approximate it, I can sketch this out. But the key thing to note here is I'm going to be looking for an area to the right in order to find the probability greater than 70 miles per hour. All right, now what I'm going to do here, because this is not in terms of z, because it's not mean 0, it's not standard deviation 1, before I can use my table, I'm going to have to convert my value to a z-score. All right, and this is my z-score formula. I take x, subtract the mean, divide by standard deviation. Okay, so x is the value that I'm looking at. All right, I want to look at a speed of 70 miles per hour. I'm going to subtract the mean, that was 67, and I'm going to divide by the standard deviation, which was 3.5. All right, now when you calculate a z-score, many times you're going to have to round. If you do need to round it to 2 decimal places so that you can take it to your table. Normal rounding rules. I just put this in my calculator, rounded it to 2 decimal places, and that gave me a z-score of 0.86. Now the purpose of this is because once we've converted to z, then we can go to our table. And once we can go to our table, everything's going to look exactly the same as it did in the previous section. So I'm going to look up the z-score, 1 decimal place on the left-hand side, 0.8. Second decimal place across the top, there's my 6. And then I want to remember where those two things intersect, I get the area to the left. All right, super important to remember that. So I look back up here where I wrote down what I was trying to find, and I say, okay, I didn't want area left here. I wanted area to the right. So I've got one more step here, which is to take the area that I just found in my table and subtract it from 1, because what I want here is the area to the right. And that will tell me the probability that a vehicle is traveling more than 70 miles per hour. The area to the right is 0.1949. Okay, so you're using the same method that you defined back in section 5.1. The only difference is if you're not given a value in terms of z, where the mean is 0 and the standard deviation is 1, you're going to have to convert it to z before you can use that standard normal table. All right, so I put one more example in here for you to use as reference, and I'm going to walk you through this one pretty quickly. So if you need to, you can kind of pause the video here and look back at it as you need to. This is a situation when we're asked to look at in between. And the main thing to note about working in between is because you're given 2 x values, you're going to have to calculate 2 z-scores. Okay, so notice what I did here. I kind of started it off the same way. I wrote down what I was being asked to find. I sketched it out. I shaded it to make sure I knew what was going on here. But then I took each individual value and converted it to z by itself. Okay, so like right here, I took 70, subtracted the mean divided by the standard deviation. Then I took the other value of 60 and did the exact same thing. And then once I was in terms of z, I said, well, I know from the previous section, if I want to find the area in between, I just look up each z-score, take the area to the left, I noted those right here in purple, and then to find the area in between, I simply take the larger area and subtract the smaller. Okay, so again, very similar section here in 5.2. The only difference is you're going to have means that are not 0 and standard deviations that are not 1. So you will have to convert to z before you can use your table and the methods that you learned in section 5.1.